Hello, and welcome to Astronomy 100. In our previous video segments, we discussed the concept behind the mechanisms of telescopes, why we use telescopes. And we talked about how there are historically differences between the types of telescopes that have been used. Telescopes started off with lenses, using the principle of refraction. These are what we call refracting telescopes. And then they moved to the principle of reflection to use a mirror in a telescope instead. And we talked about some of the advantages of each. So one of the most important telescopes of the 19th century was one that was built by a rather interesting man by the name of Percival Lowell. And it was built in a location outside of Flagstaff, Arizona. And it became one of the largest refracting telescopes in the world, a 24-inch refracting telescope. And recently we were given a wonderful opportunity to learn some of the history of this amazing observatory and learn about some of the things that had been done at this observatory. Let's have a peek at that video. Well, here we are at Lowell Observatory in Flagstaff, Arizona, and joining us today is Kevin Schindler. He's the outreach manager at Lowell Observatory. Thank you for being here.
Great to be here.
So can you tell us a little bit about the history of Lowell Observatory?
Sure. Lowell Observatory goes back to 1894. A fellow named Percival Lowell, who came from a very wealthy family, for instance, politicians, writers. His brother was president of Harvard for 24 years. His sister was the poet Amy Lowell. So came from a very wealthy family. He studied mathematics at Harvard, because if you were Lowell, you studied mathematics at Harvard. And then he spent some time in the family business, went overseas, and by the 1890s decided he wanted to build an observatory to study the supposed canals that Giovanni Schiaparelli, the Italian astronomer, had discovered in 1877. So in 1894, Percival Lowell sent a scout named Andrew Douglas out to Arizona. It was a territory, wasn't a state till 1912. And Douglas's job was to take a 6-inch diameter telescope, drag it around the territory, Tombstone, Tempe, Prescott, ended up here in Flagstaff, set the telescope up in different sites, and do site surveys, testing the sky for the quality of telescopic viewing. And Douglas spent several months out here and ended up in Flagstaff, decided Flagstaff was a pretty good site, and so Lowell decided to set up the observatory here. A high elevation at about 7,000 feet, so there's less atmosphere to distort the viewing. It was pretty close to the train, so transportation was easy. So a lot of different factors in setting it up here.
What was the population of Flagstaff at the time?
About 800 people.
Oh, wow.
And there was no electricity here.
And today?
Today about 57, 60,000, something like that. So the place has grown a lot. When Lowell came here, one of the reasons he went from Massachusetts out here to Arizona is that if we go back in time to the 1890s, electricity is becoming widespread in the cities. And of course, that's where observatories historically were, where the universities were, where the cities were, where people lived. Right. And so by the 1890s, you had light pollution from electricity. So Lowell was one of the first to realize, if you're going to build an observatory, do it away from where the cities are. And so that's why he chose Arizona. There wasn't electricity in Flagstaff yet. Flagstaff was an outpost in the Wild West, really. Yeah. And so decided to set up the place here.
Interesting. So the observatory, of course, is famous for the telescope we're standing in front of. Can you tell us a little bit about the telescope?
Sure. This telescope was not the original one that Lowell used. He actually borrowed one from Harvard College Observatory, and then one from a telescope maker named John Brashear of Pennsylvania. He borrowed those for the first season here at the Arizona, and then in 1895 he decided to order this telescope from really the best telescope maker of the time, Elvin Clark and Sons. And Elvin Clark and Sons specialized in this type of telescope, which is a refractor, which uses lenses, as opposed to reflectors, which use mirrors.
Sure.
And so this was a typical telescope of that time. And so while this telescope was being finished, Lowell decided to abandon the operations here in Flagstaff and find another site to see Mars the next year, because Mars was going to be at a nice opposition, but it would be pretty low in the sky here in Flagstaff.
Okay.
Plus that first year here was cold like today, but also had a lot of snow.
Okay.
And so they decided to find another place with a better climate.
Interesting.
And so they built this telescope in 1896. It was first used in Mexico to study Mars. And then in 1897, Lowell decided to bring it back up here and decided, although the weather can get a little chilly here and snowy, this is a pretty good site for an observatory. So this telescope has been sitting on this pier since 1897. And in fact, in just a couple months, we're going to be taking it off of here for a retrofit to rebuild it and renovate it. And for the first time in more than 117 years, it's going to come off this pier piece by piece.
Wow.
And that's going to be a pretty fabulous thing. But the reason we're doing that is because it's been used so much through the years. Percival Lowell's studies of Mars, perhaps the most important discovery made not only here, but at Lowell Observatory, started in 1912 with V.M. Slipher's first detection of the expanding nature of the universe. This was not the telescope used to discover Pluto, but it was critical in the search for what we know today as Pluto. The last major research done with the telescope was mapping the moon for the Apollo program. So several of the astronauts who walked on the moon came here to Lowell Observatory to do their training in the 1960s and look through this telescope.
Oh, excellent. So our students might be noticing that this telescope is quite long compared to the ones that we saw at Palomar Observatory. Can you tell us a little bit about the difference between a refracting telescope as opposed to a reflecting telescope? I know you said something about lenses.
Sure. A refracting telescope uses lenses, and if I can make a mini telescope right here, this is the telescope. So the light comes in here and the eyepiece is down here. So in a refracting telescope, you have a couple lenses up here, and light passes through the lenses. The lenses refract or bend the light till they come to the focus down at the eyepiece. So the wider the tube, the longer it has to be for it to come in focus. The problem with that is structurally, you can only build something so big and it's going to sag under its own weight.
Right.
The biggest refractor ever made and successfully used was 40-inch at Yerkes Observatory in Wisconsin. For a world's exposition, a 50-inch was made, but they couldn't use it. It was just too big and sagged under its weight. With reflectors, you have the light coming in here, but instead of lenses, you have a primary mirror down at this end. And there are a lot of different configurations for this, but a typical way is that light comes in, hits that primary mirror, and that bounces back to a secondary mirror that's suspended in the tube, and that bounces back to, say, an eyepiece or equipment. And so the advantage of that is that you can make the mirror wider, because the mirror or lens is how you're gathering the light. You can make it wider, but the tube doesn't necessarily have to be longer. You're bouncing the light back and forth inside. So these refracting telescopes, historically, they were sort of believed to be better for doing planetary work and detail, and reflectors were better for collecting lots of light,
for
big light buckets, for faint objects. But today, most modern, in fact, all modern research telescopes are reflectors.
So because of the size of the telescope, if the observer wanted to point it at something lower on the horizon, how did they get access to the eyepiece?
Sure, and that's a great question, because the eyepiece is right down here at the end. In some observatories, you have an elevator floor that lifts you up or down to the eyepiece. In this case, the telescope is kind of down in this pit, so we're a little bit lower. And then as you swing the eyepiece up, because the telescope's looking at something lower, you step up on these steps. And then if the eyepiece gets too high, then we have observing ladders that you can climb up the ladder, sit on the ladder, and be looking through the eyepiece. Because this is the days of research before modern technology. This was a pad of paper and a pencil, and looking hours, waiting for very quick moments of good seeing and sketching those details.
So when Lowell was seeing the canals on Mars, it was through this telescope that he was believing to see
Yes.
that. And his recreations of that show these very detailed canals that in reality ended up not being so real.
Right.
So what's the history about the consequences of his belief on those canals on Mars?
Well, you know, Percival Lowell had such a legacy, and today it's like a lot of science. We look back 100 years and say, what a bunch of morons, what were they thinking? But, you know, science is a progress report. Based on what we know today, this is the best explanation of what we have. A perfect example is Pluto. When Pluto was discovered, it was more planet-like than anything else.
Right.
But through the years, as astronomers found other bodies that weren't really completely planet-like, they decided to create a new classification called dwarf planets. The same thing sort of with Mars canals. Back in those days, Percival Lowell and others were seeing something, but they're illusory, they're not real features.
Right.
But the interpretation was some sort of intelligent life created these to bring water down from the ice caps to the dying planet for the inhabitants there.
Okay.
Today we know that those canals aren't there. We've sent spacecraft up there, we don't see them. But the impact that Lowell had scientifically, so many astronomers either wanted to prove or disprove the idea of life on Mars, because there's probably nothing more compelling to not just scientists but the average person of the possibility of life in the universe. Yeah. And so he really inspired, angered, in any way you want to describe it, got a lot of astronomers to want to study Mars a little bit more. From another standpoint, culturally, if you think about science fiction,
Right.
Percival Lowell,
Yeah.
because this is the 1890s, and he was a popularizer, much like Carl Sagan was years later, popularized astronomy. He would go on the lecture circuit, magazine articles, really popularize this idea that there's life on Mars.
Sure.
And then writers of the time like H.G. Wells, Edgar Rice Burroughs, these guys wrote novels based on this, which even more glorified the idea of life on Mars.
Right.
And so
all started right here.
It all started here, and you know, you don't see movies with Saturnians attacking Earth. It's always Martians.
Right.
It all started with Percival Lowell's ideas. So even though that's not what his intent was, it really had an impact on culture as well as the development of science.
And his legacy lives on.
It does.
Well, Lowell Observatory is a place with a lot of historical telescopes, so why don't we move on to the next one?
Sounds great.
Okay. So as you can see, the observatory outside of Flagstaff, Lowell Observatory, still is an important observatory, even though, of course, it's more than 100 years old, and the people of Flagstaff are very proud of that observatory. In the next video, what we're going to do is talk about how a telescope increases the ability to see details in things, which of course makes it also a reason to have a bigger telescope. So I hope you'll join me.